Here we are in section 5-3, exercises 5 through 10. Here we'll be factoring by grouping. Now we can tell we're going to be using grouping because we have 1, 2, 3, 4 terms. And the only way to really get 4 terms is either by pulling out the greatest common factor or having a binomial times a binomial, 2 times 2 to get 4 terms. So that's what we're going to do in this case is split this down the middle and then see if we actually get 2 binomials. So split this guy down the middle, cut him, and then what can we take out of the first half? That would be a 2m. And what are we left with when we do that? A p plus 8. And what are we left with on the second half? We look at this and we take out a plus 5, and we're left with p plus 8. And now we notice and say, hey, we have a p plus 8 in both places, so we can pull that out as a common factor of the whole big shebang. We get p plus 8 pulled out here, and we're left with that 2m and that plus 5. And now we have it factored, and it is indeed a binomial times a binomial. Great. Let's try number 6. 1, 2, 3, 4 terms. Cut it in half. Let's see if this works. And out of the first half we get, let me see, what can we pull out of 5x cubed minus 2x squared? We can pull out an x squared. And we're left with 5x minus 2. Well, let's put that in a different color so we can identify. We're left with 5x minus 2. And then on the second half, what do we pull out? We can pull out a plus, what's 35? 7. And we're left with 5x minus 2. Excellent. So now we see the 5x minus 2. We can take it both way out here, and we get 5x minus 2 out front, and we're left with that x squared plus 7. And that x squared is right there, and that plus 7 is right there. All right, number 7. 4ax plus 12ay minus 7bx minus 27by. Let's cut this guy in half. And what can we pull out of the first half? Let me see, out of the 4 and the 12, a 4. And then a, x or y, nope. So then we have 4a, and we're left with x plus 3y. And then out of the second half, 7 and 21, let's pull out this minus sign. Notice if we pull out this minus sign, then what is left, minus 7b, we're left with a positive x. Let's go back and make sure we got that second color there, minus 7b. And then what's left is a positive x. Notice how it starts to match this guy right here. If you don't pull out that sign, then you're not going to match to make these both positive. And you'll have to pull it out anyway. So x, and notice if we pull out a negative 7 out of negative 21, we get a plus 3, and then pull out the b, and we're left with a y. So we really have, and we could pull it out that way, or pull it out to the right. That's okay too, if we want to pull it out that way. And 4a plus minus 7b. All right, let's look at this. Notice we pulled these two up here, number 5 and number 6, out to the left, and this one out to the right. Does it make a difference? Well, by the commutative property of multiplication, this guy and this, if we swapped them and said x squared plus 7, 5x minus 2, it is exactly the same answer. So if you're matching these, but you put them in the different order, that's perfectly fine. All right, number 8. Let's split this one up, cut him down the middle. Let me see, 14x cubed minus 35x squared. It looks like we can take out a 7x squared. And what is it that we get when we pull out a 7x squared? We get a 2 and an x. Minus, pull out a 7, you get a 5. All right. Well, on this side, we pull out that minus sign as well. Make sure that sign matches, and out of a 6 and a 15, we can pull out a 3. And does it work? Indeed. We get a 2x, and then notice this is a minus 5. When you pull out a negative 3 out of a positive 15, you get a negative 5. And you can double check that. If you were to distribute this back through, you'd get negative 6x plus 15. And so now we pull out that 2x minus 5, and we are left with the 7x squared minus 3. Oh, good. Number 9. Let's cut this guy in half. In front here, what do we get? We can pull out a y, and what are we left with? 5m minus 1. And then we need to at least pull out this minus sign, but there's nothing common between a 5 and a 1. But when we pull out that minus sign, we're left with a positive 5m and a minus 1, which does indeed match. Now, when you pull this guy out, we're going to do this slowly so you can see what's happening. When we pull this 5m minus 1 out, from this position is left a y, and then we have minus. What do you put there? Is it a 0? No, it's got to be a 1. In order for this to undistribute and to distribute and jump back in, the 5m minus 1 would come in here and hit the y, and it's got to hit that to be exactly itself. So there has to be a 1 there. So oftentimes, if you can't pull anything out to help you see what's going on, you can put a 1 right there. And certainly you can always take a 1 out of everything. 1 goes into every single number. So that's a good way to write that. And then you can see, oh, y minus 1. That's where we get it from. All right, next, number 10. 1, 2, 3, 4, slice. What can we pull out of this side? We get 6 and a 21. What goes into there? A 3. And x squared. And we're left with, let's get a different color here, 2x plus 7. And then out of the next side, plus 2x plus 7. There's nothing that goes, there's a plus sign there. 2x plus 7, we can't really pull anything out. So it's just 2x plus 7. Notice this is very similar to what we had over here. And so if you'd like to envision that you can always pull a 1 out, always, then that may help you, because now you can write 3x squared plus 1 and then timesing it by 2x plus 7. And again, if these are written in the other order of what it's written in the book, that's perfectly fine.